All right, here we go. Let's take a look at our lesson for today. So what we have is something super exciting. It's called the chain rule. And the chain rule, I'm just going to say, we use it all the time. I really want you to think about chaining all of the time, all the time. So, and I'll explain it as we go. So here's how it works. It's a rule that we use for composite functions. So this rule is for composite functions. It's a rule that we use when the function that we have doesn't look exactly like the derivative we've memorized. So we use it when the function does not look exactly like the derivative we memorized. We'll just call it the derivative rule we memorized. So we pretty much use it all the time. We use it all the time. That's just something to keep in mind. I will have to admit that it's quite sometimes, very frequently overlooked, which is why I have a stamp that says chain rule, because my hand got so tired writing chain rule over and over again on the paper that I thought, I need a stamp. So I got a stamp that says chain rule. That should tell you to be careful. That's why I'm saying you want to always think about chain rule, okay? And it pretty much is all the time. Use when the function does not look exactly like the derivative rule you memorized. That's when we use it, which is, pretty much all the time. So how does the rule work? The way that it works is, here's our composite right here. And I like to think about them as, they're in layers or an onion. Now, I am not a cook, so I really don't have a lot of experience with onions. I know it's kind of embarrassing that I don't really know that much about onions, but I know that there's lots of layers to an onion, right? There's lots of layers. And so that's what a chain rule is. It's got a lot of layers to it. And in the most simple case, this here, right, that we're looking at right now, this is the most simple case when it just has one layer. There's just basically the outside layer and the inside layer. So when we have that, what do? We take the derivative of the outside layer and we copy and paste the inside. We're going to copy. We copy and paste the inside. Copy, if I could spell, copy and paste the inside. Okay? Then we multiply by the inside. So we're copying, pasting the inside. Then we multiply by the derivative of the inside. That's the rule. Okay, so we want to think about this as layers. We work from outside to inside. So the outside layer, copy paste the inside layer, then the next layer, copy paste, next layer, until we're already all to the inside. That's how this works. So before we do some derivatives, let's work on which, in these cases, we're going to identify which function is f and which function is g. And if we have additional ones, we'll keep going, f, g, h, however far we got to go. So we'll look at this one first. So what I like to do is actually, when I'm first teaching it, I like to put it in boxes so that you can visually see outside, inside, and the layers. That's what I like to do. You don't have to do that. But I like to do boxes when I first teach it so that it hopefully makes sense. So the outside layer, which is f of x, is sine of x. Now, I know there's not an x there. Okay, I know it's not an x. We'll just make it highlighted. It's sine of, whatever's in there. That's what f is. Then g is the inside function, which is x squared. Okay, and that's our first identification of breaking that apart. Is that okay? All right, so what I would like to recommend when we have things written like this, let's think back to our pre-cal days. What does that 2 mean? Do we remember what the 2 means? Is the x squared or is sine squared? Sine, the function is squared, right? Not the x. So it really would be to our advantage to rewrite this so that it looks more like, you know, the function is squared. That really is going to be helpful to us. So I'm going to rewrite this down here so I can do my boxes thing. So here's my outside box and here's my inside box. Okay, outside, inside. So the outside, or f of x, would be like x squared. And I totally recognize that it's not an x. There's something being squared. So think of this as just a something being squared business. Okay, so then g of x, which is the one inside, would be sine x. And there's our second one where we're just identifying which is the outside function and which is the inside function. Okay, are we okay? All right, let's do another one. So again, what I would like to do is I would like to rewrite this as ln x to the 1/2. We don't have rules on taking derivatives of radicals. We have to change the radical to an exponential. We have to. We don't have a choice. There is no rule for square, you know, that square root business. We have to turn it into a 1/2, ln x to the 1/2. So, all right, so here we go. I'm going to write it down here. So I've got ln x, that's raised to the 1/2. I'm going to do my boxes. So here's my outside box, and here's my inside box. So you can see they're nested. Kind of like those Russian dolls, right? With those nested Russian dolls where there's a doll inside of a doll, inside of a doll, inside of a doll, and however many there are. So, all right, so we've got f of x is x to the 1/2. I totally recognize that it's not really an x. It's just some clump of stuff to the 1/2, but we're going to use a power rule like we would here. So that's the outside. Then g of x would be ln x. Okay, how are we doing?
So f of x is the whole thing, g of x is what's inside.
Yes, f of x is the outside thing, g of x is the inside thing. If we think about it in layers, like the whole outside thing, the outside function, and the inside function. So here, this last one, we've got, it's kind of interesting. We've got this going on. We've got cosine. Then we've got this going on. Then we have this one. This one is 3 nested. Now, why did I have to call out the 5x? Do we have a rule? Do we have a derivative rule that we've learned? Like, did we learn the derivative of sine of 5x or sine of x? Sine of x. We learned the derivative of sine of x, right? That's why I'm trying to say this looks very deceiving, like it's okay just to say, oh, well, the derivative of sine of 5x is cosine of 5x. That's not how it works, because that's not the rule we learned. So if it doesn't look exactly like the rule we've learned, we have to use the chain rule, okay? So in this case, we've got f of x is going to be cosine. G of x is going to be sine. And h of x is going to be 5x. Okay, how are we doing?
How would we set up the chain rule when there's 3 of them, like this formula?
Okay, so we can. Why don't we do a formula to address that? Let's do a formula. I'll put another formula up by that formula that goes all the way to h, because that's typically as much as we usually go. In a rare case, we might have 4 or 5, but normally it would be 2 or 3 inside.
4 is just follow the same
It just followed the same pattern. So let's look at what if, I'll make myself some room up here. What if we did the derivative of f of g of h of x? Okay, what about that? What would that look like? Okay, that's a good rule. That's a good question. So what do? We do the outside, so F prime. We copy paste everything inside, all of that stuff. I don't care what it is. I suggest you don't even look at it. Times. Now we're going to work on the next layer. So I've taken care of the outside layer, which was F. The next layer is G. So then I'm going to multiply by G prime of, and just copy what's inside of it. Don't even look at it. Times. Then the last layer, and how I judge is I go back to this original one every time. Go back and look at this one each time. Don't try to look at the pieces that you've done out here. Go back to the first one. Okay, I've done F, I've done G, now H. Then I would multiply by H prime of X. And that would be what I would do for a 3-part one. Okay? All right, and you can see the pattern. You could continue that pattern if there's more than 3. All right, so let's do some examples.
Could you go back to that equation for just 1 second?
Yes, ma'am.
Okay.
So in the examples, I'm going to continue to draw these boxes so that you can see, I'm hoping that you can see how they are layered inside of each other. Okay, so let's do our first one. So for this one, let's see how many levels we have. We've got this outside level, which I'm going to say F is x to the 4th. Then we have this inside level. I'm going to say G is x squared minus 5. Now, you don't have to list F and G when you're working problems. That's not required. I'm just wanting to call out what is what. Okay, are we okay so far? This is a 2-parter. There's an inside and an outside. All right, here we go. So F prime of X is. So I'm going to deal with this power rule, this something, this again, this is just a blob, right? There's something to the 4th power. This something to the 4th power. I'm going to do a power rule where I'm going to bring the 4 down. I'm going to copy paste the inside and I'm going to take it to the 3rd power. That's just a power rule that we have done a lot. So I bring the 4 down, I copy paste what's inside, don't even look at it, change it to the 3rd. That's the outside, times. So I've just checked off, I've done my x to the 4th. Times. Now we've got to multiply by the derivative of the inside, and the inside is x squared plus 5, minus 5. So excuse me, the derivative of x squared is 2x. The derivative of negative 5 is 0. And that's my derivative. Now it's cleanup. Okay, so this is the calculus. That's the calculus. Now we clean up, which is algebra. Cleanup is algebra. Okay, so if we can make things look better, we should.
Why can't you just multiply the x squared times the 4x squared, then put the 8 front and just do that?
X squared times 4.
Like, just do, like, multiply the x squared by each other and then put 8 front and then
So the reason we can't rewrite this is because of this subtraction sign. That ruins all of our fun. I can't rewrite it as x squared to the 4th minus 5 to the 4th. That's not a thing. So I have to treat it as one entity. And so the only other way to do this problem would be to multiply x squared minus 4 out, x squared minus 5 out 4 times to FOIL it 4 times. Y'all familiar? Remember from algebra, right? We FOIL it. And we really don't want to do that, right? So we really don't want to do that. So really this is our only, well, it's not our only option. It's just the quicker option. Because it's we got a subtraction in there. We can't do any rewriting. So my last, we're going to clean it up by algebra. So if there are some simple things to do, we want to do it. We certainly do not want to multiply, FOIL all this business out, this x squared minus 5 cubed. We don't want to do that. We would not ask you to do that. But if I can multiply the 4 times the 2x in easily, which I can, that I should do that. So that will be 8x times x squared minus 5 to the 3rd, and that's my very first chain rule. Okay, how are we doing?
Quick question.
Mm-hmm.
How did you get? Oh, never mind. I just saw it.
Okay, no worries. All right, so let's look at number 2. And on number 2, what we're going to do is I'm going to rewrite it first because of this. We really, please do not just ignore that and try to do a derivative with that sitting there. It's just going to mess everything up. So I'm going to rewrite it with that on the outside. So I've got sine of 5x squared. Okay, that's my rewrite. Okay. So now I'm going to do the boxes so that we can try to determine how many layers we have. We have this outside layer. We have sine. And then we have the 5x. So this is 3 layers. If we wanted to list the layers, again, you don't have to do this. Sometimes it's helpful to students and sometimes it's more confusing. So just do what is best for you. So we would say f would be x squared. Of course, we recognize that this is just a holding spot. It's not really x. G would be sine. And h would be 5x. If we wanted to write them out, that's what it would look like. Okay? So now let's work on peeling the layers back. We're going to start with the outside layer first. Okay, so h prime equals. So I bring the 2 down, I copy everything inside of it, and 2 minus 1 is 1, and that's to the first power, times. I just took care of the outside layer. Okay, now let's do the next layer. Sine is the next layer. So the derivative of sine is cosine. And I'm copying the 5x in there. We're not allowed to touch the inside. We just copy it on. Times. The derivative of 5x is 5. And that's the calculus part. Now we need to clean up. That's the calculus part. Next is clean up. We need to clean up, which is, algebra. So h prime of x. And I only want to mess with the things that are easy, like 2 times 5. I can do that, and I should do that. I shouldn't leave them like it's so far apart, because they're just numbers. So that's 10. Then we've got sine of 5x, cosine of 5x, and we're just going to leave that. I mean, that's it. I hope you can see that if I miss a layer, my derivative is going to be wrong. Are you with me? If I miss a layer, my derivative is going to be wrong. We have to be very careful that we get all of the layers. Okay, now this one is going to be especially fun. Okay, are we okay? All right. So, okay, so we've got this outside layer. And we have this inside part. Now there's only 2 parts, and we're like, oh yay, there's only 2 parts, but the middle part is going to be, it's going to be intense, right? Because what rule do we have to use to take the derivative of the inside? Quotient rule. So it's going to be fairly extensive. So if I was writing what f was, f would be like x cubed. Again, we know it's not an x, it's just some bunch of stuff. And g would be it's not x cubed, we'll call it t cubed, because they're using t's. And g would be t squared plus 1 over 2t minus 5. Okay, so we've got our work cut out for us. So here we go. So f prime of t equals. So I'm doing the outside, the power rule, this 3. I bring the 3 down, I copy and paste what's inside. Don't look at it, just copy it down. And then I do 3 minus 1 is 2 times. So that's the outside layer. That wasn't really bad. That was pretty nice. The inside layer is going to be a bit more challenging because we've got to do quotient rule. We really, if there's a fraction, it's quotient rule, period. Okay, so let's write down quotient rule just so we have, I like to do that so that I can refer to it. I call it a template. So we've got FG minus FG, first things first, second things second, over G squared. That's our quotient rule template. Okay, so let's work that. So I take the derivative of the top. Remember, F is the numerator or the top. G is the denominator or the bottom. So I take the derivative of the top and I get 2t, and I copy the bottom down with parentheses. Ladies, please do parentheses. If you don't, it will get you in trouble. Minus. I'm copying the top in parentheses, t squared plus 1 times the derivative of the bottom is 2. All over the bottom, 2t minus 5 squared. Yes.
Can you find the derivatives of f and g and then plug it into that?
So I have seen some students doing that. I would say it's risky. Is it possible? Yes. But when you pull them apart and separate them like that, sometimes things get lost, if that makes sense. So I would proceed like this. I would keep everything bundled together and just proceed this way. So that's a good question. Could we do them separately? Yes, I've seen students do that. I've also seen students derail when they do that. So probably just best to leave it like it is. So are we good? Okay. So now that's really all the calculus, but we're not done. So this is the calculus. That's the calculus. We've got the cleanup. And you know what? That's the algebra part. And it's going to take a little bit of work. It's going to take a little bit of work. So what am I expected to do? I'm expected to deal with all of this stuff in here. This is not acceptable to leave that like that. That's not okay. I got to deal with all of that and then see what happens. So my first step is to deal with all of that. This is nice and compact. I'm not going to look at it. I mean, I don't need to do anything to that right now. We need to work on that piece. So that's our first step. So f prime of t is 3. And if I remembered how to copy and paste this, I would. I'm sure y'all are on that. I can't remember how to copy and paste, so I'm just going to rewrite it. So I'm going to distribute. So I have 2t times 2t is 4t squared. 2t times negative 5 is what? Negative 10t minus, and I don't trust myself to distribute the minus at the same time. I just don't. So I'm going to work on the back. So 2 times t squared is 2t squared. 2 times 1 is 2. All over, you know, my 2t minus 5 all squared. Okay. Still working on cleanup. 3 times t squared plus 1 over 2t minus 5. Okay, so here we go. So I've got 4t squared minus 2t squared. That gives me 2t squared. I don't have anything to combine with the 10t or the 2.
Wait, how did you get 2t squared?
I did the 4t squared minus 2t squared, and that gave me 2t squared. Okay. So there's actually only 2 more things that I can do, which would, so when we're simplifying, we're trying to make things as compact as possible. That's what we're trying to do. And I hope that if you look at those 2, we're going to call these are terms, right? Look at the denominators. See how they're the same? 2t minus 5. We really should bring those together. Now this is going to go back into your, algebra rules with exponents. Do we remember? I want you to focus for just a moment on this right here. Do you remember when we have some fraction raised to the second power, how we could change the way that looks? Do you remember that? We could take the top to the second power over the bottom to the second power. Remember that? That's an exponent rule, and that's perfectly allowable. And just to save some writing, I hope you don't mind if I just change it right here. Are y'all okay with that? I'm just going to change this, oops, just to save some writing, this squared over this squared. Okay, are we good with that? Now, why would I do that? Because I've got in the denominator 2t minus 5 squared times 2t minus 5 squared. What could I combine those to be? 2t minus 5 to the fourth power. Absolutely. 2t minus 5 to the fourth power. So that's what we're going to do. 2t minus 5 all to the fourth power. In the numerator, I've got this 3. I've got this t squared plus 1 squared. And I've got 2t squared minus 10t minus 2. Now, I will tell you that if this were a multiple choice question, they would factor a 2 out of here. They would factor out a 2. And multiply it by the 3. And that's what they would do. And I'm going to write that just so that you see it. So this is f prime of t. So f prime of t is, let's see, 2 times 3, 6 times t squared plus 1 squared times t squared minus 5t minus 1 all over 2t minus 5 to the fourth. And then we would stop. And you're like, how do I know when to stop? Okay, I'm in factored form. There's no pluses and minuses between the factored. We're okay to be in factored form. Okay, that's perfectly fine. Okay, how we doing? So of all of the problems, the chain rule problems that we're doing in the notes, this one is the most labor intensive. So, which means there's a lot of room for making like little mistakes, like adding something wrong or subtracting something wrong. Yes, ma'am.
Are you able to do the product rule instead of the chain rule?
Yes, yeah. And there are some cases where you have inside of the, well, all three of them bundled together in one way or another, product, chain, and quotient. Yes, like a big party, like a calculus derivative party, right? Ah, it sounds so exciting. Sorry, I'll calm down. All right, so here we go. So we got 2 more problems. 2 more. So let's do this. All right, the very first thing I'm going to do is, remember we talked about this, I can't do derivatives with radicals. I'm going to have to change the way it looks. So I'm just going to rewrite it just so that when I'm looking at it visually, I can see what I'm supposed to do. Do you have to rewrite stuff? No, you just have to know that that's to the half power, really, before we can do the derivative. So what is our, let's call it a template. So the templates that we're using are product, quotient, and chain. And actually, like you were just saying, is it possible to have a product rule in a chain rule? And this is a case right here. Because what is our overall template? If the overall, function is being multiplied, then product rule is our template. And inside of the product rule, we will do the chain rule. You with me? Okay. So here we're going to do FG plus FG, first things first, second things second. Okay, and so just to remind you, this is F. And this is G. Okay, here we go. So G prime equals. So the derivative of the first thing, which is 2x, is 2. Copy paste the second thing. Plus. Copy paste the first thing. The derivative of the second thing is 1/2. Bring the 1/2 down. 1 minus x to the negative 1/2 times negative 1. So let me encase this so we see that this is a chain rule. So those would be that's the chain rule. The outside is the 1/2, bring the 1/2 down, copy paste the inside, subtract 1, get negative 1/2. The derivative times the derivative of the inside, the derivative of 1 minus x is negative 1. Okay. So now what they want us to do is find g prime of negative 3. And I really don't want to deal with the derivative like in a big mess like this when I'm plugging in a number. That's just really confusing. Really confusing. So I'm going to rewrite the way it looks.
Where did the negative 1/2 come from?
So right here, it's a 1/2. And when I bring the 1/2 down, I'm doing my power rule. I bring the 1/2 down, I copy paste. 1/2 minus 1 is negative 1/2. 1/2 minus 2/2 is negative 1/2.
Why did you subtract 1?
Because it's power rule. I have to do the power rule.
Yes. Okay.
Yep. That's just like if I had like x to the 4th.
And that would be 3.
That would be a 3, right? It's the same thing. It's just fractions, which I know fractions are confusing.
Where did negative 1 come from?
From the chain, I'm multiplying by the derivative of 1 minus x. The derivative of 1 is 0. The derivative of minus x is minus 1. Okay, so that's my inside of my chain. Okay, are we okay? All right, so here's what I'm going to do to pretty it up, because I don't want to deal with plugging into something that looks like this. 2 times 1/2 is 1, so I'm going to really not worry about those. And I'm going to rewrite it with radicals, because that's easier to work with. So this would be 2 square root of 1 minus x, all right, and then minus, because of this minus 1, x over square root of 1 minus x. Okay, so that's just algebra cleanup. That's a cleanup phase. Why did I put the 1 minus square root of 1 minus x in the denominator of that second term? Because it's negative exponent, right? It's a negative 1/2, so it has to go to the bottom. All right, is everybody okay with the rewrite? Okay, so now let's plug in the negative 3. G prime of negative 3 equals. So I've got 2 square root of 1 minus negative 3 minus negative 3 over square root of 1 minus negative 3. I'm just substituting into the derivative. Okay, now all I'm going to do is just clean up, do my arithmetic. So that's what? 2 times the square root of, 1 minus a minus, that's plus 4, minus negative 3 over, what is that, 1? Oh, that's also a 4. Okay, so g prime of negative 3 is, square root of 4 is 2, 2 times 2 is 4. I've got the minus minus going on, so that's a plus. And then I have 3, the square root of 4 is 2. So my derivative is basically derivative at negative 3. The derivative at negative 3 is 4 plus 3/2, which would be what? 8/2 plus 3/2 would be 11/2. Help me with my arithmetic. It's terrible. Is that right? Did I add that right? Thank you. Okay, and there's our value of our derivative. Okay, we okay? One more problem. It's a two-parter, but just one more problem. And in this problem, this is the abstract. So what we're doing, we're going through different scenarios. Now we're going to go through the abstract scenario where we've got a table. We've got to read values off the table. Okay? So they want us to find f prime of 4. Well, let's work on this first one. I'm going to do little boxes. So I've got this outside function, and I've got the inside. So that's 2 layers. It's 2 layers, right? So I've got f prime of x is, so I bring the 2 down, I copy and paste. 2 minus 1 is 1, which we know we don't have to write, times the derivative of the inside is g prime of x. Okay, is everybody okay with that abstract derivative? Okay, so now I'm going to do f prime of 4. That's 2 times g of 4 times g prime of 4. Okay, so we're going to have to start getting numbers off of the table. We're going to get numbers off the table. So I'm looking for g of 4. Let's see, here's g and there's 4. So g of 4 is 3. So 2 times 3 times g prime of 4. Let's see, here's g prime of 4. So that is a negative 2. So I've got f prime of 4 is, let's see, what is this? 6 times negative 2? Is that negative 12? Right?
Yeah.
Is that right? Okay. Okay, one more. We're almost there. One more. Okay, so here's my outside. There's my inside. Are we getting more comfortable with the chain rule? Yes? Okay. So here we go. So f prime of x is h prime, copy paste, times g prime of x. Okay, good. Now we want to find f prime of 4. So that's h prime of g of 4 times g prime of 4. Okay, let's see. We need to find, let me erase this stuff up here. We need to find g of 4. Okay, here's g, and there's a 4. So g of 4 is a 3. So h prime of 3 times g prime of 4. Okay, so let's keep working it. We've got f prime of 4 is going to be, let's see, h prime. Okay, here's h prime of 3. H prime of 3 is a negative 3. And g prime, let's see where that is. So g prime is here. G prime of 4 is a negative 2. And so we get f prime of 4 is 6. Oh, sorry for the messy writing. Okay, how's that? Are we okay? Okay, very good.